reviewing the assignment. So it would not be fair to accept more assignments after we discuss it in class. So I think today, I'm sure you're all well aware, next week is the mid-semester exam week. So you'll have a mid-semester exam for this course. Did I talk about the exam last week? I think I said a little bit.
You just said that we must review on our tests.
The problem sets.
Yeah.
Okay. Which means I need to finish marking them.
Yes.
Yeah, that's, I think, one good way to study. Not the only way, but one good way. Because the exam questions will be mostly similar to the problem set questions. Yeah. Of course, the goal of any course, including a math course, is not just to learn a technique, or to say, when I see this, I do this. It's really your goal, our goal is to understand, why is it like this? We had a little bit this morning, that once we understand, then the scope of the kinds of questions that we can handle becomes much bigger. Because we can't teach or learn every kind of question that I might ever need to answer. That's why we have to develop understanding. And once we understand, then any kind of question can come and I can think about it, use my reasoning. I think I need my water. So when I say, yes, the problem sets are worth reviewing, especially, so when I say reviewing, like how do you, actually I'm curious, how do you prepare for an exam? Maybe each of you can share, what's your process, what do you do? Maybe we don't need to record this part. And I need my, is it? Okay. Is it green? It's green, it's green, okay. So, review. I don't think, did we do some systems of simultaneous equations? I don't remember.
Yeah.
We did? I don't even remember if it's on these. So, simultaneous equations. Okay. And then functions. Yeah. And then limits. Yeah. So this much was review. Functions is kind of review, but also getting into limits, which is now calculus proper. So my guess is, and based on the problem sets, but you can tell me otherwise, that this first part is mostly okay, but this, especially the limits, is where you should spend some time today to review. Is that true?
Yes.
So in a few minutes, or in a minute, I'm gonna ask Ishmael to come and share with his understanding. I told you earlier, so in a minute, not right now. In a minute. You can prepare yourself to basically, so what we were doing in the assignment, what you were doing in this, this problem set. But just before he does, I want to remind us of what is the goal? What are we trying to do? So if we have so if we have a function and a marker that works, and we want to know how fast is the function changing at some point. So maybe this is a graph of rainfall pattern, over the week, or the month, or the year. And you want to know how hard was it raining? How much rain was falling? This is the total amount of rain. So this is time, and this is the millimeters of rain. You know how they measure rain? Millimeters of rain? Basically the height.
How to measure?
You have a bucket,
Yeah.
You know how we measure rainfall? How much rain?
Rain gauge.
Rain gauge. So when we say millimeters, millimeters is the length. How does the length tell us the amount of rain? So it's very simple. If you have a container, like a glass, a bucket, and you put it outside and the rain falls. And you say, okay, after 1 hour, how high is the water in the bucket? Is it 1 centimeter, 3 millimeters, 10 millimeters, what? And then that's how much rain in that hour, or in that day. And then every day, every week you measure, and then you get rainfall. No. So we measure rainfall and we get this. But then you want to know, this tells you how much rain fell, but not how fast was it falling. When I say how fast, like, when was it a very heavy rain? A lot of water is coming down. Yeah? So the rain level is changing very fast. So you want to know how fast is the level of water changing? Is it going up slowly, but it's going to go up a lot, or is it going up quickly? Yeah? So let's say that's our question. So what we're interested in is let's say here, what is the rate of change? And the rate of change is the slope of this. This is a tangent. And we want to know the slope of the tangent line. Is it clear? Maybe it's not. Maybe I jumped too many steps. That the tangent would give you that answer. So if you say you want to know how fast is the water level changing, and I claim that the answer to that question is given by the slope of the tangent. Do you accept that, or you go, why? Is anybody not sure why that's true? Is everybody sure that this is true? Who is sure this is true? Nobody. Okay.
So that tangent line,
Yeah.
you're going to use to measure how far or what or how more or speed of the rainfall when it is falling down or
Yeah, so I have to be careful with the example. Not how fast it's falling down, but how fast is the water level rising? Is it rising like this fast, or like this slowly, or like this? How fast is the water? How much water is falling? So if I say right now, it's not raining now, but imagine it's raining. Yeah, some days it's a very light rain. It's a little bit of rain. And some days you go out and you're like, you put your head and your head is completely soaked, right? And your shirt is soaked. And other days you could walk all the way across slowly and you wouldn't be very wet still. So there's a different amount of rain coming down, right? So that's what you want to know, is how heavy was the rain? So if I'm here, and this is some time, we'll call it time 0. And there's a certain, let me take out the tangent now for a moment. We'll come back to the tangent. So all of this is to get to why do we need limits? So we're interested in limits. I mean, partly they're interesting by themselves, but actually we want limits because they're a tool. We need that mathematical concept to then get to the calculus, the derivative. So we're not going to get to the derivative before the exam. We're going to do that after the semester break. But we're getting the pieces to do the derivative. But then, in order to understand why do we even want the limit, and why do we want the derivative, we're going to look at this. So we say at some time 0, I have some amount of rain. We'll call it, the amount of rain is R0. Right? So what are the coordinates of my point here? What are the coordinates of this point?
2 and 0.
It's what?
TO and 0.
T0, and what? 0?
And R1.
And R0. Okay. Now, we wait for some time, and there's another point in time here. Let me change my function here, because otherwise it's going to give me a strange result. So let's say there was no rain, and then the rain started, and then it went like this, and no rain, and then more rain. Okay. So then I say up to here, how much rain fell in that time? So maybe this is a day. We'll call this T1. Yeah. And the amount is, can you guess what we're gonna call this? What should we call it? R1. Let's call it R1. So now our point has what coordinates?
T1 and
T1 and R1. Getting too easy. T1 and R1. So then we ask, okay, how fast was the water level coming up between T0 and T1? So there was clearly rain was falling, because the rain, the level was going up, right? So on average, how fast was it going up? Was it going up slowly or quickly? So how do we measure that? So when you want to measure how fast something is happening, you take a like before and after, and you divide by the amount of time.
Yeah.
Right? So how do we do that? So before and after. So the after is what?
After is T1.
R1. R1 is the amount. Right? Yeah, so after, yeah, the time after is T1, correct? And the amount is R1. So we want our change in rainfall. How much rain fell between those two times divided by the time difference. This will tell us how fast it was changing. Was it 1 millimeter an hour, 10 millimeters an hour, 20? So we go R1 minus R0 divided by T1 minus T0. And what we also learned then is that this calculation, delta R over delta T, is the slope. Right? It's the slope of what line? What is the line that has this slope? We haven't drawn it, so how would we draw the line that has this slope? Okay. We would connect the two dots. Let's draw a straight line from one dot to the other. Yeah? So then this is saying, this makes like a triangle. Right? And the triangle has a height of how much? What is the height of the triangle? This is delta R. I started at this level of R, and I went up to that level of R. So R1 minus R0. That's delta R. Yeah? Now, what is the base of the triangle? The delta T. Exactly. And so we say the slope of this equals how fast it goes up divided by how fast it goes forward, basically. How much it went up, we call this the rise, and this one is called the run. So we say this is rise over run. How much did you rise divided by how far did you run?
So you're running outside that slope side.
Hmm?
Okay, that you said base is delta and delta T and height is delta R. So what about how to find that side slope one?
Do you want to show me? I'm not following. Do you want to show me?
So it's like I would now, right? There. Yeah. So height is delta R
Yeah.
and this is delta T.
Yeah.
So I'm asking how to find that side.
This?
Yeah.
We don't need the length. We don't care about the length for that side. You can find it, using Pythagoras'
Yeah.
theorem. But that's not what we're doing. So when we define this slope of a line, so think about why we call it the slope. Why is this a useful measure of the slope? So if I start here and I have some lines, just different lines, some are even maybe going down. We'll come back to the ones going down. I want to compare, I want to have a way to compare how steep they are, right? So what are some ways of doing that? There's a few ways. One that you might have learned is I can tell you the angle. This might have an angle of 10 degrees. This one might have an angle of 45 degrees. This one might have an angle of 70 degrees. Right? So we could use angles. But angles are a bit difficult to, not difficult, but they require some more calculation, and you get these sines and cosines, and then it gets a bit messy. So is there another way that we could measure, find a number that tells us what is the angle, what is the steepness of these lines? So the other way we can do it is to say, okay, let me go a fixed distance. Let me go to here. And we'll call this 1 unit. 1 unit. Whatever the units are. Define the 10-degree line, then for sure I will go up but a little bit. And the steeper the line, the higher it will be after 1 unit. Right? And every line can be placed, right? If it hits here, or here, or here, or here, there's a line that goes through all of these points. And so all I have to do, really, is to measure the height. Where does the line cross this vertical gate? So then there's a line that goes through here, there's a line that goes through here, there's a line that goes through here, there, everywhere, infinitely many lines. And the higher they cross, the more steep they are, right? So instead of using angles, we could just say, okay, let me take the line and say, after 1 unit, how high did it, where is it crossing the vertical? How high is it? There's a height here, which we call the rise. In this case, the run is just 1 unit. So when we say 1 unit, if I measure it here, let's say I take this line and I say, oh, this is now 2.5 units. And it has a height of something. The height is 1.25 units. Right? In order to compare it to all the other lines, which are here, then I need to take this height and find out what is this height. Right? I feel like I might have lost you. We're not together. Aha. Okay. I don't know if I need to do this, but what I'm trying to find out is, does the concept of the line has a slope that we measure like this? I know you know the equation of the line, right? You all know y equals mx plus b. You know m is the slope.
Yes.
Yeah? But do you feel, it's one thing to memorize this. It's another thing to feel, to understand what this number means. what does it mean if this number is double, or negative, or a half of something? What happens as this number changes? If I go from 1 to 3, how does that change my line? What happens if this number goes to 20? How about if it's 1,000? If I have a y equals 1,000x, what kind of line is that? How does it compare to another line? It will be much higher, yeah, definitely. And what number do you have here when it's a vertical line?
It's very,
Yeah, so if I draw just a vertical line, what would be the equation? Y equals what times x?
zero.
One person says 0. What do the rest of us think? If I have a line like this would be y equals something. What is the something? Okay, two people say negative. Oh, one said 0, one said negative. So my hope or my expectation is you should know by now what this is. You should know that negative is not the answer, 0 is not the answer, positive is not the answer. What's left? It's not negative, it's not 0, it's not positive. What is it? It's none of the above. What other numbers are left? If it's not positive, not negative, not 0, it's not the equation of this. This is where, when I say I want you to have understanding and not just to memorize. If you just say, oh, this is the equation of the line, this is a straight line, yeah. We agree this is a line, there's no question, it's a straight line, yeah. So it should have an equation like this, but it doesn't. This is not the equation of all straight lines. This is the equation of all straight lines that are not vertical. Because verticals are x equals something. There is no y in the equation. And you should understand why this is the case. And if you don't, then you should review or try some exercise. Why is there no y? How come y is not in the equation of this, I shouldn't say question mark. Here, x equals a constant, c. This is the point, c. Right? And this, we would say, it has infinite slope. Because it has no run. You're going to take 2 points and say, what is the delta t? Okay, take 2 points on this line. What is delta t? No. Take 2 points. Here's 1 point, here's another point. 1, 1, 2. Yeah, what are the coordinates of point 1? It's c, comma, r. Well, we have R1 here. Let's call this R2. So here's R2. Here, this is the point C, comma, R3. This is R3. Yeah. So we have C. This is the point C0. So x equals C. So here we have C, R3. Here we have C, R2. Right? So now let's do delta, our equation. Right? So we have R2 minus R3, fine, divided by C C, which is what?
Zero.
Which is 0. So we have the delta R divided by 0. What number is this? It's undefined. Yeah. Therefore, we cannot write this. M is undefined. The vertical line doesn't have a defined slope. So we cannot write an equation like this for a vertical line. Now, I did this example. I was trying to explain here this idea of rise over run, the slope of the line, is not the length. It's simply a way of measuring. Is it going up a little bit, or is it going down? Or is it flat? If it's a horizontal line, what is the slope? What's the slope of a horizontal line?
Slope is 0.
Okay. The slope of a horizontal line is 0. Why?
Because
Because it is 0.
it is not.
It is not going up.
It is not okay because because it is not changing its stages.
No,
It's not changing.
if it is 0, that means it is slope. There's no point 1, that is then the percentage change line to make to after. But if it is 0, so all points are on 0. All coordinates are 0.
All coordinates are 0?
Yeah.
Are you sure?
X is 0, y is 0. Y currently X is 0.
So if I make a line like this, horizontal line,
Mesoba abathiri baje. Winga kandi ayikajwaje. Iwe graph region
Okay, X is 0. 1,
zikiri.
5,
Then mesoba kula abathiri baje ngo bana point. Wamenya zikala pili ka 0 ngo mutiri. Mesingo kayo chakula.
X is 0, Y 3. It's kind of very good.
Ka very go point. Iwe why don't do X? Iwe. This
0.3.
This is 0.
What is X is 0,
0.3.
3, X, this is X is 0, this is Y, so X is 0, Y 3, so it's here.
No, when it's
so now draw a horizontal line through that point. Draw a horizontal line through that point. So put the point first.
Horizontal.
Put the point, draw the point, 0, 3. Now we said a horizontal line, flat line, that goes through the point.
Jump and 0.
How? That's very.
It's just a point. The point is not a line. The point is just a point. You can draw a line, any line to a point, right? I can take a point and I can make any line that goes through the point, right? So draw a horizontal line that goes through that point, crosses that point. You don't have to go through the origin. You don't have to go through the x-axis.
Yeah. Well, it's
That's a vertical line.
Anyway,
yes.
This is your point, yeah? This is your point?
slope is 0.
That's a horizontal line that goes through the point. Is that a problem? that allowed?
Huh?
Are we allowed to do that?
I don't know. So you mean like this?
Our slope is 0. When x is 0, y is 3.
Okay.
So what's the equation of this line?
Like
So
wait.
this point, we said is 0, 3. What is the equation of this line?
Wait. Okay.
Okay?
Wait.
So let's think about it together. We know the equation of the line is like this. We
Yeah.
need to know n and we need to know b.
Yeah. Wait.
If
Okay.
it's a
Yes.
flat line, we said the slope is it changing?
No.
Is there when we do delta y, we do delta y. If I take 2 points, will they have a different y? No. So the difference in the y will be 0. It doesn't go up, it doesn't go down, it stays the same. So then the slope will be 0. So we know one of them is 0. Now we need to know b. Yeah? So b, what is b? Is the intercept. It's the value of y when the line crosses the y-axis. So we call it the y-intercept. B is called the y-intercept because when the line, if this was the line, this on the y-axis, this would be the value b. Okay? So here, what is the value when the line crosses the y-axis? 3. So we know n is 0 and b is 3. So now we can write y equals 0 times x.
0.
We don't need it. Plus
3.
y equals 3. That's the equation of this line. Okay. Of course, we know, yeah, it's 3. I could also write 0 times x plus 3. It would be the same. Because 0 times x is only 0. In other words, when I look at this equation, I say, aha. The function, this is still a function of x, by the way. This is a function of x which is equal to 3. So then you say, okay, give me a value of x. Any value you want. 2. Okay, when x is 2, what is the value of the function? 2. Not the value of x. What is the value of the function when x equals 2? So when it's 3. There is no x. I don't need the x. You say, okay, x equals 2. I say, wonderful, x equals 2. Your value will be 3. Here's x equals 2. There's your point. Give me another x. Not this, give me another x. 5. Okay, let's go to 5. What is the value of my function? I put in 5. F of 5 is 3. Okay. 5, 3. Okay. Anybody else? Want to give me a point? Value of x. 7. I'm going to run out of board.
Yeah, you get
1. Thank you.
You can
F, okay. F of 1 equals 3. So 1, 3. You see, for every value of x, I will be on this line. So the function and the line tell me the same thing. I can have this is called a constant function. It's called a constant function. Why? Because it's equal to just a constant. It does not depend on the dependent variable, but just the independent variable. Okay. Y does not depend on x. Y is just a constant. So it's called a constant function. And it has a slope of 0. We might run out again. I don't know why it keeps going out. Why? Do you think it will be less? Carrots? If I take a look from this point to this point, so we have this line now. So that's the line number one, line A, we'll call it. I'm going to draw a line B from here to here. Will it have a higher slope or a smaller slope than A?
Yeah. It's small.
Small.
Than
Way
A.
lower. Why? Did you do the calculation?
Just to guess.
No, then you don't guess. Sometimes in math you can guess, but this is not a place where you need to guess. You can know. It's a very simple way to know. But we didn't put numbers. I didn't even label this point. Yeah? We don't know what coordinate it has. So how do we know it will have a lower slope? So imagine in your head, yeah? I draw a line from here to here. And then I have this one. They both go through this point, right? If two lines go through the same point, that point becomes a pivot. You know what is a pivot? If you, something with a pivot. Okay. This here, so forget that it has depth, but you're just looking at, this is a line, and this is a line, right? And they pivot here, it can rotate. This can go up, and the line can go around, but it has to go through the same point here. This is the pivot. So doors are the same, they have a hinge. Yeah, if you look at the way the door opens and closes, there's a bolt. And the door, the bolt is always there. So the door can open, can move, but it has to go through that line. Right? Timothy? Are you bored or lost?
I'm listening.
You're listening. Okay. So you're bored.
No.
You're not bored. Okay. So that's the pivot, right? Now, can I take this and pull it up? Can I take the screen and pull it here
Yes.
without breaking this? I can't. If I want them to still, if I want it to still go through this pivot, then I can't pull it over. Right? I can only, I'm allowed to move it like this, but I can't, what do we call it? Translate. I can rotate, but I cannot translate. This is translation. When you go right, left, up, down, that's called a translation. You just pick it up and you move it. You can do the same with the line. And then you have rotation. So if we say we want both lines to go through the same point, the only transformation that we're allowed is a rotation around this point. I can't take a line that goes like this, or like this. They don't go through the point, right? These are translated lines, they have to be moved. So I can't move the line. If I need to go through the point, the only thing I can do is rotate. So then you say, okay, if I have this line, and I need a new line that goes through here, the same pivot, and it's going to go through a new point, then all I need to know is this line, would it have to go up? Would it rotate up or rotate down to reach that point? Are you lost? Which one? A bit of both. Sometimes feeling lost leads to feeling. Yeah? So without even drawing a line, if I gave you this one, if all you know is this line, and I give you a new point, then you can imagine, okay, this line goes. Does this line have to go down or up to cross here? If it has to go down, which it does, then it will go through the point. Well, if it rotated down, that means the slope is less. If it had to rotate up, then the slope would be more. So now let's try. If I choose this point now, these markers. If I take this point, will it have a higher or slope or a smaller slope?
From where?
From here. The same, from this same point, 0, or P0, yeah, from P0 to this new point, we'll call this point A, this is point B, and this is point C. So now, from P0 to point C, which one has the higher slope? Point A or point C? Which one will have the higher slope? Can you help us? Point C. Why? Try it. Is it easier if you try to explain and show? Try. Your friends will help you. No one's gonna make fun of you. You just know. God has spoken to you, and you know. That's one way to do math. Anyone else? Can explain why? Which one do you want to try? We will draw a line from point O, or 0, to A. And if we now draw a line from point 0 to point C, which of those lines has the higher slope?
Point C.
Why?
Because
Yes, something has to go up. So you just something goes up.
Yeah.
You would take the line that goes through A and you would have to rotate it upwards in order to reach point C. You couldn't go, if you rotate down, then you'll never find C. That's what you're saying. Yeah. Exactly. Okay. So we haven't done limits yet. How are you doing on time? Where's the So who hasn't? Who hasn't given her assignment yet? Timothy. You still want me this? Oh no, you sent it. Yeah, okay. Electronic. Good. Okay, so everybody gets their assignment. Good. All right. Enough about slopes. I hope this helps. I know we spent a lot of time on it, but it's really, you really need to, it will also come with more of the exercises we do, but you really want to have a feeling for the slope. Not just I can plug in the numbers and get a number, but what does the number mean? What happens if I change this? Okay. Mr. Krishna, are you ready?
No, I was listening back. Yes.
So what I would like you to basically take us through this, the example we talked about. Just explaining it,
The example.
the exercise.
All right.
Just explain.
That should be all.
I might need to get some better markers. These ones look like they're not. No. And that one's okay. So maybe we can start and do this.
So it's okay without this.
Not for the people who are listening.
You see?
I found it.
Yes, you are.
Don't worry, we got you. Hey, it turned off again. This thing. Why is it turning off?
Oh, right.
So you don't have to calculate all of that.
Yeah,
Just assume
Okay.
So maybe let me just say a word, what we want to cover. We'll go anyway. So in this problem, we have, like the ones we did last week, so we have f of x is x cubed, right?
Yeah.
And then we have p is 1, 1, q is x, y. And then you made a table for 1.1, comma something, whatever that turns out to be, 0, 0, 1, something.
Yeah.
And then the slope of the secant is, you could just write the number. So this is p, no, this is q. Like that. So you could just give us those numbers.
The number one.
And then,
These ones are.
Yeah.
These ones.
so
And then I put this.
this, and then explain how we think about this.
I think-
arrive at
I
this.
think we must start with this.
Yeah.
Just like this one.
Yeah.
Alright. Alright guys, so we'll start with number 5. That says use the values in the right column on the table in the preceding exercise to guess the value of the slope of the tangent line of f at x is equal to 1. So looking at these values, are they increasing or decreasing? What?
Amazing.
Looking at these values, are they increasing or decreasing?
Decreasing.
Okay, so let's take for this one. Like if the values are increasing, then we are heading to 1. Okay?
Yes.
But if they are if it is decreasing, then we are heading to 0. Okay? So with this, is it increasing or decreasing?
Decreasing.
Which means we are heading to
3.
3. Then that's the number that we have guessed, and that's correct. But sometimes maybe I should ask like this: anyone who may be confused to say which before this one and this one, which one is bigger and which one is less? Anyone?
What? What have we said?
Anyone who may be confused that between this number and this number, which one may be bigger or less? Anyone who may be confused? No.